right, so video number 2 of 3. So we're just going to do 20 through 35 or something like that. All right, so number 20, we've seen this question before. What is the slope, right, of the line? All right, well, this is in standard form, and standard form doesn't tell me squat. So if I want to find the slope of a linear equation, then I want to put it in y equals mx plus b form. Because slope is only the number in front of x if it's in y equals mx plus b form, which this guy clearly is not. So we need to solve for y. So it's the same 2 steps that we've been doing over and over and over again, right? You move your x term over by subtracting because he's positive, which is going to give me 6y equals. Now these 2 terms cannot be combined, so I'm going to write my x term first and then kick my positive 5 out to the side. Okay, you can write 5 minus 2x if you want, but I like to put my x term first. Then we need to divide everybody by 6. So those cancel, and we are left with y equals. Now we just need to reduce or clean that up. So a negative divided by positive is a negative, and then 2 divided by 6 reduces to 1/3. X plus, and I can't really do anything with 5/6, so I'm just going to leave it as 5/6. And I don't really care that my y-intercept is a gross fraction because I want the slope. Now that it's in y equals mx plus b form, right, my slope is -1/3. Please do not say -1/3 x, right? The slope has nothing to do with the x, right? The slope is the number in front of the x when it's in slope-intercept form. Okay. All right. Next up, write the equation in slope-intercept form. Okay, I'm going to stop right there. So making sure I recognize that I want my final answer in y equals mx plus b. That's the goal. That has a slope of 2. Okay, that's the m, and passes through this point, which is not a y-intercept. So you will not, I repeat, not be able to just go ahead and write your equation in y equals mx plus b form, right? Because you don't know the b, right? You don't know the y-intercept. So you have to go through point slope form to get there, right? We've done this many a time, right? So we're going to do point slope form. Right, again, it's on your formula chart. You don't have to memorize it. You just have to know when and how to use it. So if you know a point and a slope, you're going to use this guy. So here's our point. All right, so y minus the y coordinate, which is 3. The m is your 2 right there from your slope of 2. And then in parentheses, x minus, and then our x value over here is -6. So x minus -6. So it's going to create a double negative, which makes that a positive. All right, and now I need to get this in y equals mx plus b form from point slope form. So that's, again, that's 2 steps. It's always the same 2 steps. So the first step is to distribute. So I bring down my y minus 3. I multiply through by 2, so 2x plus 12. And then we're almost there. We just need to add the 3 over. So y equals 2x plus 15. And remember, you can always check your answers on Desmos. It's a great little tool now that you're able to use it, right? If I type in, I'm going to go to Desmos just real quick. If I type in the equation that I just got, y equals 2x plus 15, right? There's my line right there. And I know this has to pass through the point -6, 3, according to the question. And looky there, right? There's my point, -6, 3, and it clearly lies perfectly on the linear equation that we found, right? And so that is telling us that we have done our math correctly. Plus, he's got a slope of 2, clearly, right? So that is an excellent answer. All right, going back to our review. All right, write an equation, again, slope-intercept form. So y equals mx plus b. So clearly we need the slope. So we just talked about this earlier right here on number 19, right? You can either pick 2 points in the table and do the slope formula, or you can just calculate the change in y, which is what I'm going to do because I think that's 10 times easier, right? But it's just kind of a preference thing. I can see that my y's from -5 to 1, I'm adding 6. So that's the change in y, positive 6. And then my x's over here are going from -2 to 0, so they're changing by adding 2. So that's my change in x's. So change in y over change in x is 6 over 2, which of course is 3, or 3 over 1 if you want to write it that way. So I know my slope. Now the next thing you want to ask yourself is, do we know the y-intercept? If you happen to catch, oopsies, sorry, I'm trying to highlight here. If you happen to catch that this point right here is a y-intercept, well, you have just done yourself a huge favor, right? Because y-intercepts have a 0 for the x value, right? So my y-intercept is clearly 1. Well, if I know my slope and my y-intercept, I can just go ahead and write my equation in y equals mx plus b. I don't have to go through point slope form if I already know the y-intercept, right? And so that gives me 3x plus 1. Now, if you were looking at that table and you're like, man, I did not see that the y-intercept was given to me, then you, I'm going to put or right here on the line, then you would need to go through point slope form and pick any point. Like let's say you picked -2, 5. So you would be getting y plus 5 equals 3 times x plus 2. I'm just using the first point over here for my point slope. And then when I distribute, like we did above, we would get 3x plus 6. And then I would subtract 5 from both sides. And what do you know? When I subtract 5 from 6, I end up getting 3x plus 1. So you're going to get the same answer every time, right? It's just a matter of, do you see that you were given the y-intercept? Or, which is fine if you don't, but you just need to go through point slope form. All right, number 23, again, it says write the equation in slope-intercept form, which again, y equals mx plus b. That represents the graph below. Now, remember, in order to write it in y equals mx plus b form, you have to know the slope and you have to know the y-intercept. Now, the cool thing about a graph is I can figure out both of those things pretty easily, right? The y-intercept especially, right? It looks like it's crossing the y-axis right here. Now, you do need to pay attention to the scale because this is going by 2's, right? So this is 2, then 4. So our y-intercept is 6. Let me erase that. Sorry about that. All right, so our y-intercept is 0, 6, or you can just write 6 right there. Now we need our slope. Well, it's a graph. So, I mean, it looks like it's passing perfectly through that point and that point. So to me, it looks like I'm going, now you've got to be careful. This is where a lot of us are going to, we want to be careful. So we're going, technically, we're going up 6 and we're going right 2, right? So our slope is up 6, right 2, up 6, right 2, right? So our slope is up 6, right 2 for rise over run, which of course is 3. Now, could you do on the graph clearly I'm going up 3 over 1, but that's only reducing to the same value because the scale is the same. So you just want to be really careful. All right, and then basically we have our answer, right? So y equals, our slope is 3. And our y-intercept is positive 6. So voila, 3x plus 6. Now, if that's troubling to you, then, you can pick any 2 points on your line and you can do the slope formula and then point slope form and all that wonderfulness, right? And you can do all the work that way, but that's not how this problem is intended, okay? All right, number 24, this is a direct variation problem. Right? So remember that direct variation, let me underline here, varies directly, right? So we always say y varies directly as x. So if you were doing a graph, and you don't have to sketch the graph, but I know X is the amount of gas, so that would be gallons. And then Y is miles. Now, because it says varies directly, that means that we know this graph goes through the origin, right? So it's going to look something like this. Okay. It has to go through the origin, right? That's the definition of direct variation, which means our y-intercept is always 0, which means the equation is y equals mx plus 0, which is just mx. But for direct variation, just to be more difficult, instead of saying mx, they call it kx, because k is called the constant of proportionality, but it's the exact same thing as slope. It's just calling it something else because it's a very specific slope of a line that goes through the origin. Anywho, all right, so that it says a motorcycle travels 300 miles, that is a y value, on a tank of gas. The tank holds 4 gallons. Gallons is an x value. Okay, well, we know slope, or k, is y's over x's. Technically, it's the change in y over the change in x, but in this case, we're just going to use y and x values because we're only given one of them. So we're going to do 300 miles over 4 gallons. And 300 divided by 4 is 75. So our slope is 75. Which means our equation is y equals 75x. And the whole point of finding the direct variation equation is, now that I know y equals 75x, I can plug in any x and solve for y, or I can plug in any y and solve for x and find any missing information I want, which is the whole point, because it says how far, which is miles, so y, can a motorist travel if they currently have 1.5 gallons, which is x, of gas. So they're giving me a very specific x value so that I can take that and substitute it into my equation for x. So y equals 75 times 1.5 gallons. So that means y equals 112.5 miles. And voila. So we found our k value. We wrote our equation. Let me kind of number these just really quick. Step number 1, find the k. Step number 2, use the k to write an equation. Step number 3, manipulate the equation and solve for the missing variable. Right? That's pretty much how all direct variation problems go. All right, moving along. 25, provide an example of each. Well, an undefined slope, right? Undefined means that your rise over run, that means you're dividing by 0. And anything that has an undefined slope is a vertical line, because it's all rise and no run. Right, so that might be something that looks like, I'm just going to draw a vertical line anywhere. I'm going to draw this guy. And if I want to write the equation of that line, he is only ever going to cross the x-axis at 3. Therefore, his equation is x equals 3. Now, 0 slope, that is, of course, a horizontal line. Oh my gosh, I just wrote horizontal slope. Sorry, horizontal line, right? Because horizontal lines means it's 0 divided by a number, right? And so that means we are no rise and all run. So it has to be a horizontal line. So his equation, he's only ever going to cross the y-axis, and this guy's crossing at 5. So his equation is y equals 5. Or, of course, if you wanted to, you could write it as y equals 0x plus 5, right? And that, of course, means the same thing in this case, right? But no one really ever writes the 0x because obviously 0 times x is just 0, which is why there's no x, because this line will never cross the x-axis. All right, here we go. Number 26, a grill at a barbecue restaurant will be used to cook sausage links that are 2 pounds each and briskets that are 6 pounds each. No more than, okay, 120 pounds of sausage links and briskets can be on the grill at one time. Write an inequality to represent all the possible combinations of X sausages and Y briskets. Okay, so it looks like everything's about pounds here, right? So 2 pounds each on the brisket, right? So that's going to be 2x. And then it says briskets are 6 pounds each, right? So plus 6y. And then, of course, we are given the total, which is, again, we've talked about this recently, right? That's how we know our equation's going to be in standard form. But it doesn't say it's exactly 120 pounds, right? It says no more than. Plus, they're also telling you here that it's an inequality. So we want to definitely see both of those context clues, right? So if this represents the total amount of weight on the grill, it can't be any more than 120, which means it has to be less than or equal to 120, right? And that's it, right? That is our inequality that represents this scenario. So you can find a whole slew of points. I know this doesn't ask you to do this, but I'm just going to, so let's see, a solution. If I wanted to find a possible solution, let's see if the point, you know, if I do 10 pounds of sausage and 10 pounds of brisket, right? So if I plug 10 in plus 6 times 10, is that less than or equal to, little question mark, 120? Well, let's see. 2 times 10 is 20. 20 plus 60, this would give me 80 if I do that math. Is 80 less than or equal to 120? Yes, right? So 10 pounds of sausage and 10 pounds of brisket, that is a possible solution because I get a true statement when I plug it in, right? So little things we can do to kind of check our answers and give possible solutions. All right, number 27, the graph below shows the relationship between the number of cookies the number of cookies a presenter at a conference had left to give away, and the number of presentations she made. All right, so clearly just kind of interpreting this graph, she started with 180 cookies, right? And she gave some away at every presentation, right? And then, of course, down here, this is when she ran out of cookies, right? Because that's her 0, right? So kind of looking over here, right? That's the 0 for the cookies left. All right, so the question says, what does the x-intercept mean? Okay, well, we just talked about this, right? The x-intercept, guys, you have to be really specific. You can't just say, oh, when she ran out of cookies, right? The x-intercept is the point 6, 0. And when something asks you, what does it mean or what does it represent, you have to use both of these numbers in your sentence, right? You can't just be vague, right? You have to say after 6 presentations, because that's what x is number of presentations, right? She had 0 cookies. You can say she ran out of cookies. That would be appropriate too. I wouldn't mind that. Or you can say she ran out of cookies after her 6th presentation, right? So anything in that vibe, right, where you're actually describing, you use the number 6 and some phrase that means no cookies left. Okay. All right. 28 and 29 are graphing inequalities and then figuring out if things are solutions. All right. Well, we've done this lots and we've done this very recently also with systems, but we're just doing one inequality. So before we start, remember when you graph an inequality, it should be in y equals mx plus b form. Of course, it's not an equal sign though, it's a less than or greater than, I realize, right? But remember all those rules we talked about just the other day, right? If it's got an equal to bar, it's a solid line. If there's no equal to bar, it's a dashed line. Greater than means shade above, less than means shade below. If you divide by a negative, you have to switch the inequality symbol, right? So there's a lot of things to remember when you graph an inequality. All right, so this guy is not in y equals mx plus b form, so we're gonna do that. So we're gonna subtract 2x from both sides. Same old, done this a million times. So 3y less than or equal to, I'm going to write my x term first and then kick my positive 6 out because now it's starting to look like mx plus b, right? And that's the goal. My last step though, I don't have the y by itself, so I need to divide everybody by 3. I do not flip the inequality symbol because I did not divide by a negative, right? I just divided by a plain old positive 3. So I'm just going to keep the sign the same. And that's going to give me negative 2/3 for my slope. And then positive 6 divided by positive 3 is positive 2. So this is the inequality that I'm graphing. And before I graph it, I just want to do a quick analysis of our symbol here and what this means. Right, so I've got the equal to bar, which means it should be a solid line, solid black line. And then y is less than the line, which means we should be shading below. Right, so I just want to always have that in mind before I start graphing. So our y-intercept is positive 2. Our slope is negative 2/3, so down to right 3, down to right 3. Or if I want to go backwards, up to left 3. I should definitely have a decreasing line because my slope is negative. These are things you want to check. All right, and it is a solid line, so I can go ahead and connect all the dots. And it's a less than, so we're going to shade everything below the line. Right, so this is our solution region here. I'm just going to kind of lightly shade it here. Okay, so any point on the line or in the pink shaded region is a solution to this inequality. Right, so solution region, right? Everything in here. Whoa. Okay. All right, so then it says down here, it says, is 5, 2 a solution? All right, well, 5, 2, that's this point right here. Is he in my shaded pink region? No. All right, so no, he is not a solution. All right, number 29. All right, so graphing this one, he's already in y equals mx plus b form, right? Notice the slope is 0, all right? So it's a horizontal line. There is an equal to bar, so that's going to be a solid line. And this one's also less than, so it's going to be shading below. So remember what y equals 3 looks like, right? That is a horizontal line only crossing the y at 3. And it's a solid line, so we're good to go there, right? And then we're shading everything below because it's a less than symbol. So everything in this shaded region is a solution. Sorry about that. All right, so everything here. All right, so on this one, it says, is 5, 2 a solution? Same point. Let's go see 5, 2. Yep, he's in my solution region. So yes, he is a solution to this inequality. Okay. All right, number 30. We're getting to the stuff that we just took a test on recently. All right, so write an equation in slope-intercept form. All right, so that's y equals mx plus b. That is parallel. So remember, parallel means same slope to y equals negative 1/3 x minus 5. Now I like this because he's already written in y equals mx plus b form, which means his slope is 1/3. And we also want it to go through the point 0, -7. Now, I always like to do this. You don't have to, but I always kind of like to keep track over here of everything I know about my new line. I know he has to have the same slope as this guy, so -1/3. And he has to pass through the point 0, -7. Now, I don't know about you, but I'm kind of doing a little happy dance when I see the point 0, -7, right? Because he is a y-intercept, right? Yay! All right, we love getting y-intercepts. We can just hop right to y equals mx plus b form right now. Now, if you don't catch that, then that's okay. I'm going to do it the long way, but if you happen to catch that that's a y-intercept, then you can just hop right to your answer right now, right? The answer is y equals -1/3 x minus 7, but only if you recognize that. If he's any other point, then this wouldn't work. So I'm going to do this the long way. I'm going to do point slope form, right? Y minus y1 equals m times x minus x1. So here we go, y plus 7, because the double negative. My slope is -1/3 x minus 0. All right, that's point slope form, but we got to get it into slope intercept form, so it's the same two steps. I'm going to bring down my y plus 7. I need to distribute. -1/3 x is -1/3 x, but -1/3 times 0 is just 0. So if you want to put a plus 0 over here, you're more than welcome to. And then, of course, we need to get that y by itself, so we're going to subtract 7 from both sides. Scooch all that up a little bit. There we go. And so my 7's cancel, and that's going to get me y equals -1/3 x minus 7, which again, I already knew that was coming because the point they gave me was the y-intercept, which is super awesome. All right, the next one, write an equation in slope-intercept form that passes through the point 0, -6. Oh my gosh. Why are they making this so easy on us? Right? If you notice that that's also a y-intercept, because y-intercepts have an x value of 0, all right, then we can just hop right to our answer here in a second. Is parallel, okay, so same slope again. But it's parallel to 6x plus 2y equals 8. Well, unfortunately, I don't know what the slope of that line is because that is in standard form. So I'm going to need to put him in y equals mx plus b form really quick. And so let's see, 2y equals, I'm going to put the -6x in front and kick the +8 out to the side because that's my constant. And then I need to divide everybody by 2. 2, 2, 2. So that gives me y equals -3x plus 4, which means that his slope is -3, right? But that's my old line, right? So I want to keep track of the information for my new line that they want me to write the equation of. And we're trying to be what? Parallel to this guy, which means we want the same slope. So if this guy has a slope of 3, then we want our new line to also have a slope of 3 and go through the point 0, -6. So again, if you're quick, right, you should just be able to hop right to y equals mx plus b right now because that's the y-intercept. Right, but only because there's a 0 in the front. If this number right here was anything else, we wouldn't be able to do that. So if you don't understand what I'm saying, then just always go through point slope form. Like always, don't even question it. So I'm going to do it the long way. Y plus 6 equals m x minus 0. And then the same two steps again, right? Distribute. So y plus 6 equals -3x plus 0, or leave the plus 0 off. That's totally up to you. And then we'll subtract the 6. So y equals negative 3x minus 6. Well, of course it's negative 3x minus 6, right? Because that is the y-intercept point that they gave us. Usually you're not that lucky, right? We're trying to kind of speed things along for you on the review a little bit, so it's not taking you forever. All right, number 32. Write the equation in slope-intercept form that passes through 0, negative 3. Oh my goodness, we did it again. Right, that is a y-intercept because the x value is 0 and is perpendicular. All right, so remember, perpendicular lines have opposite reciprocal slopes. So many of you guys on your test, you only took the opposite slope, like you changed it from a positive 4 to a negative 4. Right? And you just can't do the opposite. It has to be the reciprocal, which means to flip the fraction, right? So you have to do both. Take the opposite sign and flip the fraction, okay? So luckily for us, this equation is in y equals mx plus b form. So clearly the slope of the given line is 2. But, go over here, I'm going to keep track of all my information for my new line. And we want his slope. We don't want it to be positive 2. We want it to be the opposite reciprocal of positive 2. Please remember, every slope is a fraction. Right? If it's not a fraction, you make it a fraction by putting it over 1. Right? 2 is the same thing as 2 over 1. So the opposite reciprocal would be negative, because the opposite sign, and then the reciprocal of 2 over 1 is 1 over 2, right? Opposite reciprocal, and it has to go through the point 0, negative 3. So I have a point, I have a slope. You can totally do point slope form, or the quick way would be to recognize that they gave you the y-intercept, which is awesome. But I'm going to go ahead and do it the long way once again. So y plus 3 equals negative 1/2 x minus 0. Right. Y plus 3, I'm going to distribute, which is going to give me negative 1/2 x plus 0. And then, of course, we need to get that y by itself. So y equals negative 1/2 x minus 3. And feel free to use that Desmos, right? Type in this original function, type in your new one, go look if it's perpendicular. All right, if you get the wrong slope, then you're going to realize it pretty quickly if you use Desmos to check your math. All right, just a few more to go. Number 33, write the equation. The line is perpendicular to the y-axis and passes through the point 312. I highly, highly, highly recommend anytime it mentions an axis that you sketch the graph. This is a very easy problem, but so many people miss it because they just don't want to bother sketching the picture and actually seeing what's going on. So I'm going to go ahead and plot 312 is pretty high up there. So let's say 3, 1, 2, 3, and then I go up 12. I'm not going to draw all those, but let's just say that's this point. Right? So let's say that's the point 312. Here's my x-axis. Here's my y-axis. All right. So now it says we want to be perpendicular to the y-axis. Well, remember, perpendicular means intersecting at a perfect 90-degree angle. So if I want to be perpendicular to the y-axis, that means I have to create a 90-degree angle with the y-axis. So that's this line right here. So we want the equation of a line that only crosses the y-axis. And of course, what value is it crossing the y-axis at? Well, it has to be 12 because it's going through the point 312. So our answer is the equation y equals 12. Okay. All right, our next one says, given the function f of x equals x. All right, that is the parent linear function. Just a little reminder. Again, that's all on the last page if you need a refresher. Parent linear function. So it has a y-intercept of 0 and a slope of 1. So up 1 over 1, up 1 over 1. Right, so it's that nice perfect diagonal through the graph. This is your parent linear function. Right, so this is f of x equals x, or y equals x. It's the same thing. All right, so I've graphed f of x. Now I want to graph a new function that is telling me to take my old function, f of x, and subtract 3 on the end. Well, you need to remember from our transformations what that means, right? So minus 3 on the end means that we're going to shift or translate down 3. So literally all we have to do is just take this original line that we graphed and move every point down 3. I still have a slope of up 1 over 1. I've just moved everybody down 3 units. So there is our new g of x function. Okay, so just glance over your rules that are in our notes. Remember, you can also do this in Desmos. I can't say this enough, right? If I go into line 1 and I type in f of x equals x, right, there's my parent linear function right there. And then I literally just type in exactly what's on my paper. G of x equals f of x minus 3. And there you go, right? My red line is the original. The blue line is what minus 3 tells me to do, which is clearly moving it down 3 units. Okay, so as long as you know how to type it into Desmos, Desmos will kind of show you the way. All right, here we go. 35, the table shows the heights and lengths of several rectangles. What does the correlation indicate for the strength of this linear association between these guys? Hold on one second. Okay. Well, correlation coefficient, just to recap, that is the lowercase r, right? And I know this isn't, I'm just going to recap what this means, right? R is a value between -1, I'm going to put a 0, and +1, right? Right, it's a scale. So I'm just going to kind of draw this, right? 0 means no correlation whatsoever. +1 is a perfect positive linear relationship where everything falls perfectly on the line. -1 is also a perfect relationship. It's just a negative, right? And 0 is just all over the place, right? Like your eyeball sees no pattern whatsoever, right? So wherever your R value falls in there, the closer you are to 1, the stronger the relationship, right? Whether it's a +1 or a -1, right? Those are both perfect correlations. So the closer you are to plus or minus 1, the stronger the relationship. The closer you are to 0, the weaker the relationship, okay? And of course, the positive versus the negative tells you what your slope is. Okay, well, I can't find the R just by looking at it, so I'm going to have to put all this in Desmos. All right, that's a lot of numbers, so let's get cracking. Here we go. Desmos, let me take all that out. Hit the plus sign to enter a table. All right, here we go. 41. I just kind of like to enter all my X's, so I can just hit the enter. 21, 34, 10, 92. And you got to be careful if any of your numbers get off track or you enter one wrong number, right? It's going to throw everything off. So you want to be super careful. I always double check mine before I move on to make sure I didn't make some silly typing mistake. 24, 10, 35, 42. Okay, that looks good. Now I'm going to go put in all the Y's, making sure they match up with their X's. I don't want to get off track. 25, 32, 12, 16, 45, 40, 23, 45, 35, 21, and 14. Okay, hold on just a really quick glance. 21, 25. I hate to do all this work and then accidentally miss a number. Okay, those look good. Now, do you see that little magnifying glass in the blue bar right up to the left? I'm going to hit that, and look at that, right? That's like a crazy, there's all my coordinates that just plotted right there. That's kind of a mess, right? But let's see what Desmos gives us for the R value. So I have to go run the correlation. So remember, I have to type in the Y1 and then my little squiggly for approximating, and then mx sub 1 plus b. Right, that's how we tell it to run a regression. And you should be able to see all of the statistical data in the box. If you don't see that, then you typed in the instructions wrong, right? You typed in that y equals mx plus b incorrectly. Look at that R value though, 0.1555. All right, remember that, 0.1555. Okay, I'm just going to say 0.16, round to 2 decimal places. Okay, so my R value was 0.16. Can I go back really quick to our Desmos? Do you see that line they drew? Right, it's kind of got just as many dots above as below almost, right? It's like the average. My eye does not really go that direction. It's that top right point that's kind of pulling it upward, right? Other than that, it doesn't look very correlated at all, which is what the R value is trying to tell us. An R value of positive 0.16, right, means this is a very weak, I'm very close to 0. My graph almost kind of looked like that. It just had kind of 1 or 2 points out here that kind of drew it up to the upper right. But this is a weak positive correlation. Right? And you must have both words. The weak describes the strength of how closely packed it is around the line, right? And positive describes the slope. Okay? So weak positive correlation. We're used to everything being, you know, strong correlations, right? So this is a good example of one that's weak. All right, that should do it. I already had the video made for the last half or the last 10 questions or so. All right, well, happy studying. Make sure you come to class with any questions so that we can go over anything that you need help with.